Okay, so how can we determine the pattern of inheritance when we look at a pedigree? That's the $1,000,000 question, right? This is what students are going to have to be able to do. So there is a little system of rules on how to determine this. I have really a few rules here, but two basic rules. If there are way more males than there are females, okay, that are affected or that they're shaded in, then the pedigree is tracing a sex-linked trait. So that's one sign. If you don't see that more male than female affected situation, then you want to look for two parents that are the same shade, meaning either filled in or not filled in, and that they have children who are different from them. Label the child homozygous recessive, and then the parents heterozygous recessive. Once you work out your Punnett square, you can determine if the child was shaded, then the pedigree is autosomal recessive. And if the parents were shaded, then the pedigree is tracing an autosomal dominant trait. This does have some subjectivity to it, so it's not always perfect, but it's just kind of a helpful strategy when you're trying to look at a pedigree and figure out what type of pattern we're looking at. We're going to look at a couple examples. So here I have a pedigree, and I have, this is dad up here. We want to know what dad is, right? We have mom, right? She is affected. She doesn't have any daughters that are affected. She does have nobody, I guess, who's affected. But it looks like this daughter decided to marry a male who was affected. So the fact that we see it in this parental generation, but we don't see it in their offspring right here, means that this is likely going to be recessive. All right. So this dad right here is definitely going to be homozygous dominant because mom can only give a little R, and she does that. She has to give a little R to everybody. And since nobody has the trait, then everybody got a large R. All right? Now, it's possible that dad could have been big R, little r, right? He could have been heterozygous and just given everyone that R. That's also a possibility too, which is why we represent this as R question mark. But it doesn't matter because all of his children got a dominant trait. Okay, so then this daughter right here, she has a marriage with her husband who is affected. And so he is homozygous recessive. That means all he can give is a little r. And he gave a little r to both of these sons. But this mom right here, she can give that R dominant trait or the recessive trait. She gives this kid the recessive trait and this son over here the dominant trait, leading with one affected and one non-affected son. So this is a great example of an autosomal, meaning it's not on the sex chromosomes because both girls and boys have it, and it's recessive. Recessive meaning that it is skipping a generation because it is also masked by the dominant trait. Now let's take a look at another example here. This is going to be sex-linked recessive. So we have a dad. This dad is affected. His X has the recessive gene on it, and he's affected, and he also has a Y. All right, so this mom over here, she has an X. It is a dominant gene, so she's got a good X, but then she also has a recessive X that is affected. This man right here can only give his sons the Y. And he can give his daughters this X recessive, because that's all he's got to give his two daughters. But mom, she can potentially not, she has this dominant trait, so she gave this daughter and this daughter, that's an X, I'm sorry, the dominant trait. So each of these daughters have a dominant, it's being masked, they're not displaying this trait. This son, however, he He could have gotten, mom's dominant trait here, but he didn't. He got X, the recessive trait from his mom. How do we know that? We know that because it's showing up now in his offspring. See, in his offspring, the Y component right here went to his sons, which is here. But in order for his daughters, one of them to be affected, they were going to have to get his X little r, right? Both daughters got his X little r, the recessive affected X chromosome. One daughter has it and the other one doesn't, because this mother has a dominant trait and a recessive trait. And so this recessive trait went right here, making this homozygous recessive sex-linked, this daughter affected. And the recessive trait, the dominant trait goes to this daughter. And so this daughter right here is unaffected because she has one dominant trait that she got from her mother.